SQL injection has been on the OWASP top 10 since the list existed. It has caused some of the biggest data breaches in history, and it still shows up in modern applications because the fundamental mistake, concatenating user input into SQL queries, is easy to make and easy to miss in code review. Today we are going to understand exactly how SQLi works at the database level, how to find it systematically, and how to confirm it before we move into full exploitation tomorrow. Let me start with the core mechanic. When a developer writes a query like select star from users where username equals quote, then pastes in your input, then closes the quote, they have created a situation where the database cannot tell the difference between the developer's SQL and your input. If you type a normal username like admin, everything works fine. But the moment you type admin followed by a single quote and 2 dashes, something fundamental changes. Your quote closes the string that the developer opened. The 2 dashes start a SQL comment, which tells the database to ignore everything after it. If there was a password check after the username check, it is gone now. Comment it out. You just authenticated as admin without knowing the password, 130 to 230, now finding injection points in a real assessment is more systematic than just throwing quotes at login forms. I follow a 3-phase detection approach. Phase 1 is error-based discovery. Inject a single quote into every parameter you can find, URL parameters, form fields, cookies, even HTTP headers like user agent and referrer. Watch for database error messages in the response. If you see anything mentioning SQL syntax, unterminated strings, or specific database names like MySQL or PostgreSQL, you have a strong signal. Phase 2 is Boolean confirmation. Compare 2 requests, one with a condition that is always true, like or 1 equals 1, and one with a condition that is always false, like and 1 equals 2. If the application returns different results, your SQL logic is being interpreted. Phase 3 is time-based testing, 2:30 to 3:30. Once you have confirmed injection, the next question is what type of extraction you can do. The fastest method is union-based injection, where you append your own select statement to the original query. The catch is that union requires both queries to have the same number of columns. Finding the column count is simple, use order by and increment until you get an error. Order by 1 works, order by 2 works, order by 3 works, order by 4 gives an error, so the query has 3 columns. Now you build your union select with 3 values. Set the original query to return no results by using an impossible ID like -1, and your injected row becomes the only result, 3:30 to 4:30. One mistake I see constantly is people only testing with quotes. Numeric parameters often go into SQL queries without any quoting at all. The query says where ID equals and then just drops your number in directly. No quotes to break out of. In this case, you do not need a quote, just append your SQL after the number. Type 1 space or 1 equals 1 dash dash, and you have injection. If you inject a quote into an integer context, you will get a syntax error and might conclude there is no vulnerability when there actually is one. Always check the parameter type. If it looks like a number, try payloads without quotes first. Now not all SQLi gives you visible output. Blind SQL injection is when the application does not display query results or error messages. You can still extract data, but you do it 1 character at a time. For Boolean-based blind, you ask true or false questions. Is the first character of the database name greater than the letter M? If the response matches the normal page, the answer is yes. If it differs, no. Binary search through the ASCII range narrows each character down in about 7 requests. Time-based blind works the same way but uses response delays instead of content differences. Both are slow compared to union extraction, but they work. In situations where nothing else does. A few practical notes that will save you time. MySQL requires a space after the double dash comment, or you can use a hash sign instead. PostgreSQL and MS SQL accept double dashes without the trailing space. This syntax difference causes more failed injections than people realize. Also, web application firewalls will block obvious payloads like or 1 equals 1. In real engagements you will need to encode payloads, vary casing, or use logically equivalent expressions to get past filters. We will cover WAF bypass techniques later in this challenge. For practice, I strongly recommend the PortSwigger Web Security Academy SQL injection labs. They start with basic visible output scenarios and progress to blind extraction challenges. DVWA is another solid option for getting hands-on with these techniques in a safe environment. Start with the easy labs tonight, because tomorrow we are going from detection to full exploitation, extracting password hashes, reading files off the server, and in some cases turning SQL injection into remote code execution. See you then.